Okay, so here's the illustration for the KKT conditions. So here is the level set of the inequality constraint. So basically, if you say this side, it means lower, smaller than 0, and this side is greater than 0. So the same for this and same for that. Therefore, the inside will be the feasible area, which means the answer should be only be here. And then now look at the actual function. So we want to find the minimum of such function that is inside the feasible area. Therefore, you need to find out this tangent line where the level set will cut actually the feasible area, like the earliest it cuts. So when you actually cut this point, we'll know that basically the linear combination of the, let's say, the gradient of the function at this point should be equals to basically all the negative gradient of the active constraints at this point. So therefore all of them sum up should be 0. So simply that's the first condition, because they sum up to 0. It's basically it's a linear combination of so basically all the the active constraints for g functions, they'll have and the function f, there will be a way to linear there will be a linear combination of all of them together will be 0, simply because of this fact right here. It's the gradient of the function can be a linear combination of all the rest of the constraints. And here we have for all of the inequality constraints, we have this term is satisfied because this point is in the feasible area. So all of them satisfy. Everything's it's smaller than 0. So and then we need to prove that the why it's all greater than 0 for the active constraints, because they're all in the opposite direction of delta f. Let's see. So it's supposed, like, gi is supposed to go this direction, gj is supposed to go this direction. So everything is opposed the direction of delta f of gradient f. So in that case, because we want to make the combination, we want to have the gradient equals to 0, so all of the lambdas should be greater than 0. And then for those who's not active, basically they're not really in this combination, so we want to leave them out in this case. Therefore they're 0. They're insignificant for the question.